Two, one.
So this is the Litterbug by Josh.
I'm Mason.
I'm Colin.
I'm Ankit.
So our problem statement is the process of cleaning litter for governments or businesses. We are designing a system to collect and store trash with properly dispose of it. Background information. Our group identified that littering is the issue we should face. It's a growing problem in populated areas. Waste is often improperly disposed of, and both businesses and governments spend billions of dollars picking up litter. So our target customers will be business owners, government, and household usage. The government will have use for this for again crowded areas, picking up trash. Store owners would have use for this for things like cleaning up messes in their business, and then household owners can utilize this product to improve sanitation in their house. So the people we interviewed was my dad, Ankit's dad, Mason's assistant store manager, and Colin's dad. Um, they all think that a design that will clean up their work areas will be useful and accepted to them. They thought we need something small and compact and ability to pick up medium-sized objects. Based and our customer feedback based on our final design, they think that all of our requirements were met. Things like the final cost might be something that we should calculate better, and the distance sensor with Arduino to detect trash and obstacles could be better, along with our vacuum.
So our design requirements was that it shouldn't be larger than 29 by 22 by 41, and that it should hopefully be able to lift around 25 pounds. That it should be able to pick up 2 pounds. It should be able to detect and respond to obstacles in its way, and it should have an easy way to access the storage and remove it. So here you can see the CAD assembly that we had made. It was a small scale version to the base our prototype off of. And then here you can see our final prototype. You can see we made some small minor changes. These were that we flipped the lid around so that we could have easier access to the vacuum and electrical components, and that we added a second distance sensor to the back so it could detect better.
And then the overall circuit function of our robot was it was made up of two distance sensors, like Colin stated before, and five motors, including the motor. That's including the motor of the vacuum. It was connected by two breadboards, and we used the three L293N motor controllers, which controlled the wheels, and also a servo motor, which hit the button of the vacuum. And then what's we call it? Essentially, we used three 9-volt batteries and the battery that came with the vacuum, which was a 6-volt high amp battery to power the entire circuit. The main change that we would do for the next project would essentially just be put in place a better system to organize the wiring layout, because going to the next slide, you could see in the top right that it was just a real mess, and debugging it was a very lengthy process as a result. And then you can see all the fundamental connections that you can't see in the top right photo and the bottom right photo of our Tinkercad model, which did have a few drawbacks and restrictions due to Tinkercad. Essentially, we had to use the L298D motor controllers as opposed to the L293N motor controllers. But they're essentially the same things, similar. And the Tinkercad also didn't have a 6-volt battery or anything like that for the vacuum, so we had to replace it with a 9-volt. But other than that, you can see all the basic connections in the bottom right of the screen, and also you could look at our schematics on the left. And this is a flowchart of the overall functions of our robot. essentially the robot is powered, and once the robot is powered, it activates all the sensors and motors and all that. And if the front distance sensor detects anything within 30 inches of it, the robot will turn right. And then if the rear sensor detects anything within 5 inches of it, the robot will stop. Otherwise, the robot will just continue forward.
So the Arduino program lets the motors know and motors move and let the distance sensor know what to do, and it helps make the distance sensor control the motors on the program. So for our code, the first part of our code was defining the variables and range of values that each pin can hold. So we used all 13 pins on the Arduino, and the servo had its own code. Next, we had to define whether each pin was an output pin or an input pin, and then we also set the servo to be 90 degrees at the beginning. Next, we looked at the distance sensor, servo, and serial monitor code. We set the distance sensor to measure the distance in inches and relate it back to the serial monitor. We did that for both the back and front distance sensor. And as soon as the code initiated, we set the servo motor to turn on the vacuum. Lastly, if the distance of the back sensor was less than 15, the Litterbug stops, and if it was greater than 15, the Litterbug would go straight. If the distance of the front sensor was less than 30, the Litterbug would start to turn to the right to avoid obstacles.
This is the demonstration video of our project. As you can see at the beginning, as you can see at the beginning, the robot stopped once it's powered because it detects something within 15 inches in back of it. And then as you can see, once something is in 30 inches in front of it, the robot turns to the right. And then you can see it here at the end, it stops when something is 5 inches in back of it. And then going into what we would improve, we would add more distance sensors around it just to detect the environment a little bit better, along with making the design overall less box-like. Because the issue we kept running into was you'd get too close to the wall and then hit the wall with the corner of the box. And then we'd also make the vacuum more powerful as well, because we had some issues with it actually picking up stuff. And like stated before, we'd have better organization of the wires and connections and all that.
For our testing procedures, we tested each component before we put it into the assembly. We tested the durability of the frame along with motor mounts, and we ensured coding worked properly. To debug, we also tested all the wires to ensure all the power was going through. This helped us take out the faulty wires.
And this is the materials list. Essentially, it all came down to around $50.
This is how our work was divided for the project. As you can see, we all gave our fair share, and that's how it ended up.
So this is our market value. Our Litterbug is in between a street sweeper and a Roomba, and that's why we think it'll be more effective.
Lessons learned. Overall, we found that planning is very crucial to the project's success. We need to check our work twice next time. Nothing comes out as planned or perfectly. If we could restart, we would put more time to coding. We would check things twice and spend less time sitting and more time acting, even if we didn't have the components.
And this is our reference slide.